Hello, and welcome to the Geotechnical Engineering Podcast. In this episode of the Geotechnical Engineering Podcast, I'll be talking with Stan Wurst, Operations Manager for the Midwest and Mid-Atlantic Division of Schnabel. We'll be talking about the ever-changing profession of geotechnical engineering and earth retention projects and how things have changed over the past 20 years. And I'm your host, Jared Green, and this is the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. And with that, let's jump right into today's episode. All right, Stan, welcome to the show. Glad you could be here, man.
Yeah, thank you very much, Jared. Glad to be here.
Excellent. How have you been? It's been a while since we last chatted, but how have you been?
I've been doing really good. Obviously COVID is something that, is affecting everyone, and I'm actually working from home right now.
Okay.
I still am traveling for work, but besides that, business as usual, and things are very busy. So that's a good thing.
Excellent. No, it's good to be busy. It really is. And, adjusting to the new normal or whatever you want to call this is something that we've been in for a while. It's a challenge, but we'll get through it,
Yep. No, it is a normal by now. So
yeah,
we're all used to it.
Excellent. Well, I'm glad you could be on. If you could take our listeners through, kind of insights through your career journey, that would be helpful. And then also walk us through what do you do now on a daily basis?
Okay, sure. Well, I guess I'll start back probably around the time that you and I first met back at University of Illinois. I got my bachelor's and master's degree in civil engineering from U of I. The master's, that was back in 2002. And I think that's about the time you and I met in a geology class.
Yeah.
We were probably a year apart or something. You were just coming in from Syracuse, I think.
Yeah.
But so I got my master's, structural geotechnical emphasis, the usual there. And, I started working for Schnabel right out of school. I've been there ever since. So that's been a little over 19 years now. I started off with them as an intern over the summer, the year before I graduated. And at the end of that summer, I got offered a full-time job for when I graduated the following year and decided to accept that. I've been here over 19 years. I started off as a typical project manager, designing, managing the earth retention projects that we do for the most part. And that lasted maybe 3, 4, or 5 years until I got into bidding and estimating, helping to bring work into the company. And the way we were structured back then, you did it all. You bid the work, you design the work, you negotiate the contract, you manage the work, you close it out, every aspect of that. So I spent a lot of time doing that, getting very familiar with all aspects of the business. And I would say maybe 5 or 6 years ago, we had a change in our company, and we started up what we call a special products division. And I focused on sequent piles and jet routing, relatively new technologies that I was taking charge of developing those for our company, getting in different markets, trying to advance those technologies, our knowledge of that and how we perform those. I spent a few years doing that. And then just recently here, a little over 2 years ago, we combined some offices that we have at Schnabel and formed 3 main groups around the country. The group that I am now in charge of the operations for as an operations manager is called Group North. That involves the Midwest, the Mid-Atlantic, and the Northeast. So I don't know, over 24 states or so that I'm overseeing right now. And really what I do is I supervise, I train, I develop, I recruit project managers to manage the projects that we get. Part of that also involves the design, part of that's also contracts. Basically every aspect except the bidding part, the pre-construction, that's a separate group that we have, but everything to do with operations, I'm in charge of for our group in the company. Does that make sense? So, day to day, I'm working with project managers in the Midwest, out in the DC area, up in Philly, helping to make sure we're doing the projects according to our design, or if someone else designs it according to how it should be done. Developing new talent, trying to find new people to bring into the company, and developing relationships with our clients so that we can get more work as well. So again, a little bit of everything, but it's taken me a while to get to where I am, and I've seen a lot in that time.
Excellent. Well, it sounds like you definitely have your hands full.
That's an understatement. Yep.
Wow. Well, I'd love to talk more about earth retention projects. I make sure I say it correctly, because I know where I'm from, we call them supportive excavation projects. But if you could talk a little bit more about that for, we have listeners that are still in school, they're still in grad school or in undergrad, and still learning about those things. But tell us a little bit more about earth retention construction. What is it? What isn't it?
Right. Yeah. So earth retention system, supportive excavation, shoring, sheeting and shoring. It's referred to a bunch of different names. It's very locally referred to around the country, different geographic locations. Basically what it is a wall of some type, whether it's cut off or not, for groundwater, that supports the excavation from falling into the excavation itself, supporting buildings, roads, utilities, adjacent structures, anywhere where an excavation cannot be laid back, as if you're in the middle of a cornfield. So it varies from just 5 or 10 foot high to, we have projects right now that's going 65 foot deep in the DC metro area. Multiple levels of underground parking garages, usually parking structures, basements. Sometimes it's landslides, constructing a wall that is typically tied back with an external lateral support to prevent it from tipping over. But earth retention systems can be, like I mentioned, water cutoff or not, sheet pile, secant pile, jet grouting. Those are all water cutoff type systems where water does not flow through and hydrostatic forces are actually being resisted and designed for by the wall. But the more conventional type of system is soldier beams and wood lagging. That allows water to flow through. It's not used for below groundwater, but typically shallow, less than 30 or 40 foot deep. That's a very common flexible system that's used. And again, each geographic area, we work all over the country, has their own, time tested and developed type of shoring system that they use that works in their geologic area.
Excellent. And Stan, I'd be curious for the projects you're working on, are a lot of these design build, or are these design bid build? Like, what are you seeing as it relates to earth retention?
Sure. So the majority of what we do are design build projects.
Okay.
And by that, I mean, or I could actually back up and say they're bid, design, build. We bid the job, we get it, then we need to design it. We do a preliminary bid design during the bid process, but once we get the job, we actually design it. The reason for that is earth retention systems are not a common thing in the grand scheme of structures of buildings. Not all consultants who are designing structures or civil works know how to do that. So a lot of times it's put out to the specialty subcontractor, which is, Schnabel is one of those, to bid and design, take responsibility for that ourselves. So I would say that's around 75% of what we do. We design our own work and then construct it. The other 25% would be pre-designed. I think that's something you and Langen get into a lot, is pre-designing for either owners or general contractors. And then what would happen at that point is the general contractor would put that portion of the project out to bid. And a company like Schnabel would put a cost of that and bid it, and then we would build what's actually shown on those drawings, as opposed to coming up with something ourselves.
Got it. And when you look at earth retention projects, one could say that they've become more complex. We could say that they've grown, but over the last 20 years, what type of changes have you seen?
Definitely more complexity. I would say when I first started doing this work, things were, again, relative to where they are now. They were fairly straightforward and simple. There was a design developed for the building, for the project. We were able to design our system according to the ground conditions. We went out and built it, and it was as simple as that. I cannot remember the last time we did something that simple. Right now, I could rattle off half a dozen different projects right now that we're in the middle of redesigning for various reasons. Most of what I've seen is that projects are being pushed to get started before they're finished in the design stage.
Yeah.
And by that, I mean the superstructure itself either is not fully completed. They think they know what they need to do underground so they can get started. And that's where we come into play. But the entire superstructure isn't completed. And during the process of us either designing or starting to build the job, changes get made, typically due to cost, due to funding. Private developments have a lot of those issues that they work through, and they start to redo the depth, the layout. We come across utilities that no one knew were there, underground structures that no one knew existed. Fun cities or railroads that used to exist, that
Tunnels,
people just
right?
backfilled over. There's a ton of stuff. There are very few undeveloped land areas, in major cities right now. Everything is being reused for good reason. But we're coming across a lot of, 100-year-old developments that are buried, and they're whatever you call them, obstructions, design challenges. Stuff like that. It's just nothing is straightforward anymore. I would say, again, that's a relative term, but these jobs are getting so complex. They're difficult to design. They involve lots of redesigns based on what we encounter, and it's more challenging for the companies and the people involved in managing that too. You got to adjust on the fly, be able to change what you're doing, have more flexibility in the system. And that takes a lot of effort. So that's something I've definitely seen here recently.
Yeah, there's no new land. So the land that we're working on now, it's like there's a reason why some of those sites haven't been developed. It's challenging, right?
Yep.
And I think even from an exploration standpoint, when we're trying to put together bid documents for earth retention, let's say, the borings are important, the cone penetrameter tests are important, but it's almost like the test pits become even more important. And how many test pits are appropriate? It's like, it's tough. It really is tough. When you think about the earth retention projects you worked on, some of the more challenging ones, what's one that you think really benefited your career as an engineer?
Well, the first one that comes to mind is the Red Rock Hydroelectric Dam in Iowa. That's one that just recently won an award from PTI, Post Tensioning Institute, as well as the DFI's outstanding project this year.
Congrats.
We were involved in the tiebacks on that job. And those tiebacks were installed through a secant pile system and our tiebacks actually were drilled underneath an earthen embankment right next to the hydroelectric dam itself, extending underneath the lake that was behind there. That was the source of water for the dam. And what I'll say about that job is we did not do design work on that, but what it really imparted to me was all the little details that go into building a job, even if we're only installing tiebacks, that really affect the cost and the design of how they were started. And what I mean by that is, it's simple enough to come up with forces and loads. It's what we do are basically a statics problem. We like when things don't move, so statics, not dynamics.
Not dynamics.
But the details of how we get to the end product are really important, especially on, this ended up being 100-foot deep excavation. We had up to, I want to say 17 strand ties. So, testing to 500 kips, 500,000 pounds. A lot of the things that you do with smaller loads, you can't do with larger loads. A lot of the connection details, would crumple under these higher loads, what we would normally do. We had artesian water conditions to deal with. So not only drilling through that, but then sealing it so we don't lose ground at the end were very important. And again, you could look at this project from the standpoint of, okay, we have loads to resist. We're going to install tiebacks, end of story. But it's all those little details that really help me on future projects to either make sure we understand the cost of doing that, but also to make sure our clients, whether it's another contractor, whether it's a consultant or an owner, understand the repercussions of, if this is what you want to do, this is the effort it's going to take, and these are the risks. That job was very risky, but that's also what made it fun. Doing jobs that aren't risky, those are boring. So,
and for that job, were you involved on the design side? Were you involved on the field operation testing side? Like, where was your involvement on that one?
So I was the one who originally estimated that job and got it for our company. And then I was involved to varying degrees with the construction of it, some of the detailing, and figuring out some of the problems that we encountered there.
Excellent. So I can imagine that after a project like that, the next project you go to, whether it's deeper or shallower, you're thinking about all the lessons learned from that project. You're taking them forward, right?
Yep. Usually after a project like that, the next project is a lot simpler, regardless of what it is.
Yeah.
But one of the challenges that I find myself facing is whenever we have a really challenging project that forces us to reevaluate or think how we do things or take more details into account. If I carry those forward to the next job that's much simpler, a lot of those things are not necessary. Yeah. And that can lead to a greater cost if I try and apply the things that I learned on a much more complicated, higher load project to a simpler one. Yeah. So it's hard to make sure, you're not applying something where it doesn't need to be applied.
Yep.
Both from a design standpoint and from a construction and cost standpoint.
Yeah, you're absolutely right. You're absolutely right. And there's no real formula for how you figure that out. I guess it's just with experience, you start to see what's going to be appropriate for this job. The given challenges, what's going to be appropriate for this job.
It's a lot of experience. Mm-hmm. Yeah, I know we're, when we graduated from U of I there with a master's, I don't know about you, but I'd say I probably know, I learned 10% of what I know now in school. Most of what you learn, I'd say is from working.
Yeah, I agree.
For me, being in college, I learned some of the basics and I learned how to learn. Mm-hmm. But once you start having experiences and run work, see what the real world is like, that's where the real learning happens.
Yep, you're absolutely right. I remember when we'd be in school and you hear people talk about engineering judgment. I'm like, what page of the textbook do I get that? And it's like, it's not for the textbook. It's from being out there,
That's right. That's something you can't read about.
You can't. Well, oftentimes a challenge for engineers is when they start to become managers and they're responsible for not just projects, but people. And when you think about leaders and you think about engineering leaders and what makes them good and what makes them bad, what are some of your takeaways? How an engineer becomes a good leader or a good manager? What does that process look like?
Well, if I knew 100% the answer to that, I'd be a much richer person and would have a company myself developing engineers.
Yeah.
It's a challenge. And, I think a lot of people have different paths to becoming managers or leaders. One thing I know is, when you graduate from school with an engineering degree, I would be willing to say most people do not have the background or are not prepared right off the bat to be managers. And by that, I mean, if you're going to school to be an engineer, you learn calculations, you learn the concepts. We hire a lot of interns and co-op students at Schnabel, and I'm usually managing most of those and hiring them. And one thing that I really try and get across to them is that all the information that they know doesn't mean anything if they cannot communicate that to someone else. And so I think to become a manager or a leader, communication means more than anything. If you know how to do stuff, the only reason that's good is if your job involves just doing things yourself. But we all know you need to work as a team. You need to communicate with people above and below you, different companies, internal, externally. And communication just cannot be stressed enough, in my mind, to students and new hires who are trying to figure out how they want to progress in the field and do more with their career. That's one of the things that I notice seeing a lot of new students coming out of school.
Yeah.
I don't know do you see anything similar yourself?
I do. I think that, when you're in school, a lot of times you're focusing in on the calculations and solving problems. But, when you start working, almost like those first few years, a lot of what you're doing, even if you do a calculation, you have to be able to explain it. And when
That's right.
students don't know how to explain, it really puts them at a disadvantage. And I also find that, if you go to the field and you're looking at, let's do a test pit, you're looking at a test pit and you can't explain what you saw. It's like, well, why did we send you out there? What were you doing at that 8 hours?
That's right.
You can't show me a plan and a cross section, maybe even an elevation of what you saw. That's problematic. And I think that that's just something, it's kind of hard to teach it in school, but you do learn that during your internship, co-op, or your first few years at work. You start to say, wow, when I go out there, these are the things my manager asked me to do, and I need to make sure I do those, whether it's a checklist or sticky notes and things you need to make sure you capture. I remember the thing for me was, what are the elevations, right? You have a ground surface elevation. So what's the elevation at the bottom of a test pit? You can't give a sketch that doesn't give that. And I remember when I get that circle, I'd say, oh, yeah, I got to make sure I know that for the next time, right?
Yeah, no, and you bring up a good point. When I was in school, you were handed all the givens for your problem. Yep. You were handed the height, the elevations. You were told what the soil properties were. And the biggest challenge, I think, in working is you need to find the givens yourself.
All of them.
You need to define them. You need to figure them out. And most people coming out of school just don't have no concept that, oh, you're not just telling me everything I need to know. I need to figure that out. That's a new concept.
Yeah. And you got to justify it. I mean, if you tell me you're using a friction angle of 37, why are you using the friction angle of 37? Explain that.
That's right. You got to be able to communicate it. Being able to look back, almost 20 years now from being removed from school, it is fun and interesting to see, where we started and seeing some of that and the new people that are hired right now. It's a big learning curve, but I think we're all still learning, and that's what keeps it fun.
I agree. What advice would you give to kind of like the next generation of engineers? What are some of the things they should be thinking about when they're in school, when they're looking for a job, and when they're starting?
I think, keep an open mind. I had no idea exactly what I wanted to do when I was in school. I knew I wanted to do something civil engineering related. That I was able to narrow it down to that. But I'll say I didn't even know that Schnabel existed until I started working for him. I did not know this was an industry. I did not know I had a passion for this stuff until I started doing it. So even though you may go in with a certain mindset to school that, hey, I want to design buildings, I want to do, I want to build bridges, which I think most people who go into civil engineering, that's what's in the back of their mind. I want to build bridges. There's a lot else out there, and you can find your little spot in the world that you excel at, whether it's small or big. Keeping an open mind, I think, and staying flexible is very important, because if you have your mind set on one thing and that doesn't pan out, you got to be able to switch gears and do something else.
Excellent. Well, I think that's a good note to pause on. We're going to come right back and Stan in our career factor safety end segment. Stick around. Welcome back. It's time for our career factor safety end segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're talking with Stan Wurst. Stan, you've already had a very successful career. And when you look back at that career, what's one thing that you implemented to give yourself, let's call it a factor of safety in your career?
There are a few different things. I feel very fortunate to have been in this business for as long as I have. Also understanding I still have at least that much time left till I can retire.
Yeah.
But one thing I think about both looking back and going forward is being able to take care of yourself and to take a long view approach in mind, not just thinking about today or this year, but what am I going to do that's going to have an effect years from now, either for myself or for someone else. And especially this past year and a half with COVID, it's really put a lot of stress, I think, on people personally. It's put stress on businesses and made things harder to get things done, whether it's with supply chains or just time and managing your own time. Recognizing both yourself and for other people that we are people and not machines, I think is very important to give some credibility to the fact of, we're trying to do this as a career. We're trying to build projects that, however small or large they are, contribute to something greater, and to have a sense of accomplishment for that, I think really helps to get past the day-to-day stresses that may get you down. And if we're going to be doing this for, you and me another 20 years or so here, I think we need to keep that in mind. Otherwise, it's very easy to get burned out. I've been up against that a lot with, overworking myself or seeing others, and being able to recognize that in yourself or others, I think is very important and healthy for, the long term, both as, you as an individual and for your company.
Thank you for that. We're talking a lot more about mental health and avoiding burnout and taking care of the whole person. We're talking more about that now than we were in times past. And it's
Absolutely.
so crucial. It's so important. So important. All right. Well, Stan, thank you so much for coming on, and you shared a lot of great insights with us. And I'm sure you shared information and advice that'll be helpful for our listeners. If there's a listener that's checking this out and wants to reach out to you, what's the best way for them to get you? On social media or an email?
I'd say via email would be the best way to reach out.
All right. What is your email address?
Email is my full name, stanley.wurst@schnabel.com. I'm assuming you can post that to either the website or something here, but yeah, if anyone's interested in reaching out, I'd be more than happy to start up a conversation or talk with anyone about, anything that's been discussed here or more. So no, I've had fun, Jared. Thank you very much for this opportunity.
Oh, that's great. Thanks. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 34, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.